Today's lesson is 1.5 angle pair relationships. The first vocab term we need to talk about is supplementary. Supplementary are angles that add up to be 180 degrees. Complementary angles are angles that add up to be 90 degrees. And then we also have adjacent angles, and those are angles that share a common vertex and a common side. So a few tips and tricks to remember these vocab terms. Supplementary starts with S, and S comes after C in the alphabet. And likewise, 180 comes after 90 when we're counting. So complementary starts with a C, which comes before S in the alphabet, and 90 comes before 180 when we're counting. So complementary is 90 degrees, and supplementary is 180 degrees. Adjacent. Adjacent is a new vocab term, and I like to think of adjacent as, you might say, I live adjacent to somebody, and someone that you live adjacent to is someone that you live next door to. And I don't have a fence, but if I did, the person that lives next door to me, we would actually share that fence line. So angles that are adjacent share a common vertex and side, just like I would share my fence line with a neighbor that I live adjacent to. We also have what are called linear pairs, and linear pairs are two angles that form a straight line. Notice we even see the word line in linear pair. So if you have two angles, such as this one, we have angle 1 and angle 2. That is another way to name angles. If you ever see numbers inside your angles, that is another way to name them. So angle 1 and angle 2 form a linear pair because they form a straight line. What we know about that then is that since they form a straight line, they are also a straight angle, which then means that if you have a linear pair, those two angles are also known as supplementary angles. So I also know then that since they're supplementary, the measure of angle 1 plus the measure of angle 2 would add up to be 180. I would also like to take note that those two angles, if you notice, they share a common vertex right here and a side. This also means that linear pairs are also adjacent to each other. So we can also say that those angles are adjacent. They are next door neighbors. Then we have vertical angles, and vertical angles are when you have two lines that intersect. So here's line 1, here's line 2. They definitely intersect. And when that happens, the angles directly across from each other. So for instance, angle 2 and angle 4. Those angles are called vertical angles, and what we know about vertical angles is vertical angles are congruent. So you can see right here it says angle 2 is congruent to angle 4. That means they have the same measure. So the measure of angle 2 and 4 are identical, and then likewise, since angle 1 and 3 are across from each other, those are also vertical angles, which means angle 1 is congruent to angle 3, which means their measures are the same. Now notice my arc marks. Angle 2 and 4 only have one arc mark because those two angles are identical in measure. And then angle 1 and 3 have two arc marks because those two angles are identical in measure. All four cannot have the same number of arc marks because they're not all four the same measure. We're going to use that vocabulary now to find the value of x. So in this first example, we see that it says angle A and B are complementary. So since A and B are complementary, we know that the word complementary now means that they add to be 90 degrees. So what that means for us is that the measure of angle A plus the measure of angle B, those are going to add up to be 90 degrees. So that's exactly what we're going to do. The measure of angle A, which happens to be 15x plus 3, plus the measure of angle B, which happens to be, that does not look like a B, which happens to be 5x minus 13. That is going to equal 90 degrees because they are complementary. Then we're going to simplify the left-hand side of our equation. So we're going to combine like terms. 15x plus 5x is 20x. 3 minus 13 is negative 10, and that's equal to 90. Then we're going to undo our operations in reverse order. So I'm going to undo subtracting 10 by adding 10. And I'm left with 20x equals 100. And my last step would be to undo the multiplication with division. So I'm going to divide both sides by 20 because what we do to one side, we have to do the other to keep our equation balanced. And so x equals 5 in this specific case. If you notice, if we were to actually, you don't have to do this, it's not a requirement, it doesn't say to, but if we were to take 15 times 5 and add 3 to it, we would see that this angle is 75 plus 3, which is 78. And then if we do that with the second angle, which was angle B, 5x minus 13. So if I take 5 times 5 minus 13, 25 minus 13 is 12. You will see that if you add 78 and 12 together, you get 90 degrees because those angles are complementary. And then likewise we're going to do over here, we have the angle A and B this time are supplementary. So instead of adding to 90 degrees, we now know that these two angles are going to add to 180 degrees. And we're going to follow the same process. The measure of angle A plus the measure of angle B is going to add up to be 180 degrees. So we have the measure of angle A, which happens to be 3x plus 2, plus the measure of angle B, which happens to be x minus 4, is going to be equal to 180 degrees. We're going to come through and we're going to simplify the left-hand side of that equation by combining like terms. 3x plus x is 4x. 2 minus 4 is negative 2, and that's going to be equal to 180. And then we're going to undo those operations in reverse order using inverse operations. So we're going to undo subtracting 2 by adding 2, and what I do to one side, I have to do to the other to keep my equation balanced. So I now have 4x equals 182. And then my last step will be to take 182 and divide it by 4. And 182 divided by 4 is going to give us 45.5. So x is 45.5. For example 2, we aren't necessarily given any verbal information, it's just a picture, so we have to identify what type of relationship we see in this picture. So if we look at example C, we see that we have a straight line. So we have two angles, right here we have angle DEG that has formed a straight line with angle FEG. So those two angles are called a linear pair. So they form a straight line, so we call them a linear pair. And when we have a linear pair, we know that those angles are supplementary, which means they add up to be 180 degrees. Not only are they supplementary, they're also adjacent because they do share, if you notice, they share a vertex E, and they also share the side right here. So they're also adjacent angles as well. That doesn't really give us any numeric data that we can do anything with. We're really using the linear pair, which means they add up to be 180. So we're going to take that and we're going to take our first angle, which was angle DEG. So the measure of angle DEG, which was 18x minus 9. We are going to add that to angle FEG, which was 4x plus 13. And since those angles are a linear pair, we know that they add up to be 180 degrees. So we're going to do exactly that. Then we're going to look to see if we can simplify on the left-hand side, and we can. 18x plus 4x is 22x. Negative 9 plus 13 is 4. And then we are going to work those order of operations in reverse order using inverse operations. So I'm going to undo my addition with subtraction. So I'm going to subtract 4 from both sides to keep my equation balanced. That leaves me with 22x equals 176. And then I'm going to undo my multiplication with division, making sure I do that to both sides to keep my equation balanced. So I'm going to take 176 divided by 22, and we are left with x equaling 8. So my solution there is x equals 8. Now in letter D, it did not ask for us to find x. It actually asked for us to find an angle. It asked for us to find the measure of angle SQP. So eventually we are going to find the measure of SQP, which is an angle we actually don't have an expression for in there. So we're eventually going to have to find that angle. But what we do see is we see two intersecting lines. I have line RP that intersects line ST. And when we have two intersecting lines, we do know that the angles across from each other are called vertical angles. So these are vertical angles. And what we know about vertical angles is that they are congruent. That means they measure the exact same. So in this case, I know that angle SQR is congruent to angle PQT, which means their measures are going to be exactly the same. So I know that the measure of angle SQR, which is 12x minus 13, has to be the exact same, meaning equal to, the measure of angle PQT, because they are vertical angles. So 4x plus 3. I can't simplify anything on the left or the right-hand side, so I need to make sure I isolate my variables by getting all of my variables to one side of the equation. So I'm going to move my 4x to the left by subtracting 4x from both sides to keep my equation balanced. So I'm left with 8x minus 13 equals 3. Then I'm going to undo those operations in reverse order using inverse operations. So I'm going to undo subtraction with addition, making sure I do that to both sides to keep my equation balanced. And I'm left with 8x equals 16. My last step is to undo that multiplication with division. So I'm going to divide both sides by 8, and we are left with x equals 2. That is a nice, pretty number to use because we are going to have to actually use that to find the measure of this angle up here. So I now know that x is 2. That means I can substitute 2 in for x. So instead of that saying 4x plus 3, I can now take 4 times 2 plus 3. 8 plus 3 will give me 11. That means that this angle is 11 degrees. Since my vertical angles are congruent, I also know that this angle over here is 11 degrees. However, that's not the angle that I was asked to find. I was asked to find the measure of angle SQP, this one up here. So in order to find that SQP, which is the one at the top, I am going to have to look at another relationship. So the relationship I'm going to look at is this linear pair. So if you notice, I have a straight line right here. I'm going to do that in black, dark black, so we can see it. So I have a straight line. And I know that the angles that form that straight line should add up to be 180. So I know that this angle right here plus this angle right here should add up to be 180. So if that orange angle is 11 and I'm trying to find the green angle, and they're supposed to add up to be 180, I can take 180 minus 11, and that's going to give me 169 degrees. So my angle is 169 degrees. So when I ask you to find the measure of angle SQP, the measure of angle SQP is 169 degrees, because 169 plus 11 will give you 180 for that linear pair. And last but not least, it says find the value of x and y. When we're finding the value of x and y, you can only solve equations with the same variable in it. So when I see all of these expressions, I have to look at the two that have an x in them and start with those two expressions first. So I have to ask myself, what type of angle relationship exists between the 5x and the 12x minus 41? And if I'm looking at that, I see that those two angles formed a straight line. So I know that those form a linear pair. So you can see right here, there is a straight line. So we have a linear pair. Since they are a linear pair, we know that those add up to be 180 degrees. They are a linear pair. Linear pairs add up to be 180 degrees. So I'm going to take my 5x, and I'm going to add it to my 12x minus 41. And I know those two angles together equal 180 because they are a linear pair, which means they are supplementary. And then I'm going to simplify my left-hand side. 5x plus 12x is 17x. Then we're going to undo those operations in reverse order using inverse operations. So I'm going to undo my minus 41 with adding 41. So I'm left with 17x equals 221. And then my last step would be to divide by 17. So I'm going to take 221 divided by 17, and that leaves me with 13. So x is 13. Now I have to use my angle relationship that has a y in it. So what I notice is I have two intersecting lines. When I have two intersecting lines, I know that the angles across from each other are called vertical angles. And what I know about vertical angles is that vertical angles are congruent, meaning they measure the same. Well, the cool thing about this is I now know that x is 13, so I'm actually able to substitute in x and then figure out how much that angle actually measures. So I can take 12 times 13 and get 156, subtract 41, and this angle is 115 degrees. That means that 5y is also 115 degrees. So instead of looking at all of this information with the x in it, I now know that this angle over here is 115 degrees. And then I know that those vertical angles are congruent. So that means that 5y also has to be 115 degrees. And this is a one-step equation. I just have to divide both sides by 5. So 115 divided by 5 would make y equal to 23. That's it. And then if you want to, you can try the last one on your own and pause the video and then restart it when you're finished. Okay, for the x's, I know that these are vertical angles because we have two intersecting lines and they're across from each other. And we know that vertical angles measure the exact same because they are congruent. So I'm going to set those two angles equal to each other. I'm going to collect all of my variables on one side, so I'm going to subtract 3x from both sides. I'm left with 7 equals 2x minus 35. I'm going to undo my operations in reverse order using the inverse operations. So I'm going to add 35 to both sides, which leaves me with 42 equals 2x. And then the inverse of multiplying by 2 would be to divide by 2. So in this case, x is 21. And you can use that same relationship for the y's. So for the y values, these are also vertical angles. And so those two angles are also congruent, meaning they measure the same. So we can set 3y plus 5 equal to y plus 75. Again, I can't simplify on either side, so I'm going to collect all of my variables to one side. So I'm going to subtract y from both sides to keep my equation balanced. So I'm left with 2y plus 5 equals 75. And then I'm going to undo those operations in reverse order. So I'm going to undo addition with subtraction. And then I'm going to undo multiplication with division. And so y would be equal to 35. That's how we use angle relationships to find the values of x and